In Module 2, we're going to talk about report authoring roles and the tools that people in those roles use to create reporting solutions. We'll start with a discussion about authors and developers. Then we'll talk about the tools that report authors and developers use to create reports and report solutions. Then we're going to transition and talk more about the nuts and bolts of reporting services. And we'll talk about reporting services architecture and the environment, both the server environment and the design and development environment. We'll talk about sources of report data, and then I'll conclude with two different demonstrations. The first is a tour of the sample and demonstration database that we're going to use, called the Wide World Importers Data Warehouse Database. And then we'll navigate a dashboard report solution from the perspective of the report author and the report developer.
All right, we're back here with Paul. And Paul, we want to talk about why I would want to use SQL Server Reporting Services, right? Our course is called Analyzing and Visualizing Data with SQL Server Reporting Services. But here on edX, we also have a course called Analyzing and Visualizing Data with Power BI, Analyzing and Visualizing Data with Excel, and now SSRS. What does SSRS bring to the party? Why would I use this rather than the other?
Well, a lot, but you're asking a complicated question that comes up all the time. I've been using reporting services for 13 years.
Right.
And, at the time, that was the reporting tool that we would use, sans Microsoft Access on the desktop.
Right.
But, we have a lot of choices. And the answer to the question, which product do I use, is always, as a consultant, it depends.
Sure.
And, the conversation I have with consulting clients all the time, conversation I have with students all the time, because reporting services is such a mature product, it's been around for a long time, it still fills a lot of gaps that Excel doesn't, that Power BI doesn't. We use it for operational reports. We can still use it to create dashboard-style reports. It really is a very comprehensive tool. So within reporting services, there are a lot of different kinds of people who use it. So you've got casual users, you have more technical users. You think about all of the roles of the people who might need to create a report just to look at data or create something very complicated that might be integrated into a solution. I mean, think about who those people are.
Sure. So if I'm just getting started, it sounds like it makes sense to learn reporting services. It's not been replaced by Power BI, or certainly not by Excel.
Nor will it
Why not
be anytime. Sure.
Okay. All right. So let's talk about those roles. I mean, if we had to think about the types of people that are going to be using reporting services, creating reports and reporting services, they're going to range from experienced database developers and business intelligence developers at one end, perhaps, to business analysts who really know their data well, but maybe aren't that comfortable with databases, don't have a lot of experience. They just need to build their report, and then in between. So how do we guide them into learning about reporting services? We've got multiple tools to use.
Sure. Well, and rather than iterating through all of those different roles and all the different hats that people might use, let's put them in two different groups, and we'll call them report authors and report developers. The report author might be your more casual user or the more business-centric user. They don't care about writing complex queries. They don't want to write a lot of code. They don't want to use complicated tools. They just want to create a report.
So somebody for whom creating reports isn't their primary role.
Sure.
It's part of what they do, but it isn't what they're focused on 100% of the time.
Sure. And so Report Builder is a tool that's a little more document-centric. Creating a report is a little more like writing a Word document than it is developing a solution.
Right.
But for the true report developer, the IT-centric developer, the solution developer, the BI architect, that person's probably already using tools like Visual Studio. So they're accustomed to tools that manage multiple reports in a project, where they can collaborate, use version control, share and collaborate with other team members. So I think that a Visual Studio tool like SQL Server Data Tools is a natural fit for people in that role.
Sure. And it sounds like there's a lot of overlap between what the two tools can do.
There is. And I would say that if I had to simplify that, I would say that 80% of the features overlap between the two tools. And so if I'm a more complex report developer, that doesn't mean that I'll never use Report Builder. I like using Report Builder. It's simple and easy to use. But as a developer, there may be capabilities that I would
would prefer to use within Visual Studio.
Right. So if I'm back in that role of somebody who's just getting started with all of this, I haven't learned a lot of querying languages myself. Right. Report Builder is something that I can use, though, to leverage what other people
Right,
do.
which is why we're focusing this course on using Report Builder.
Right.
But I think that Visual Studio may be in your future.
All right. And we're going to talk about both those sets of tools in the next module.
There are different roles and different personas of people who use and create and work with reports. Let's take a look at some of them. Information workers are people who work with data with an eye on the business. They may need to create simple reports. They may just need to browse and navigate and work with data within reports that have been created for them. Data analysts need to go a little deeper, working with data so that they can analyze and understand it, performing calculations, and looking for insights and answers to questions. Information consumers are generally readers of data. They may be customers or vendors. They might be employees within an organization, but their concern is not creating a report or deeply understanding the data. It's just simply running a report and being able to read it and get the answers that they need. Business managers and leaders, they're running the business. They need information so that they can make critical decisions and be able to provide leadership to others. They may or may not be interested in actually working with that data, but some may play dual roles as an information worker or an analyst, or maybe just an information consumer. The difference is that business managers and leaders use that information to make critical business decisions. Solution developers focused on using development tools, writing code, writing queries, probably designing more advanced reports, or designing applications that reports would be integrated into. And then finally, system administrators. They're charged with keeping everything running, allowing access to things, and making sure that our networks, our resources, our report servers, and the data that are presented through them are secure and only available to those people who should have access to it. We're going to take all of these roles and boil them down into two different categories, and they are authors and developers. So report authors generally need to create reports in a fairly simple and straightforward environment, where the developers need a little more flexibility and maybe a little more technical capability. So let's think about the tools that are used for authoring and developing reports, and specifically those that are provided with SQL Server 2016. How do you choose the right reporting tool? Well, for report authoring, typically the report author is going to be creating a single report created by one author. They are accustomed to using software, and so they may prefer to think of the report as a document. They create it, they save it, and they put it in a portal. So their method for creating reports is to create the report and deploy it. There it is on the server. They can run it, they can use it, it's available for others, and if it needs to be modified or changed, then they simply change it in place on the server. The theme here is simplicity. When thinking about report development, developers may create multiple reports as part of a solution. And as in the continuum of the business, we may be creating a lot of reports over time, and all of these reports need to be managed and packaged and perhaps consolidated and updated. So not only are we managing multiple reports, perhaps in the concept of a project or a solution, but teams of developers may be managing multiple reports. So we need a tool that allows a team to collaborate, to be able to check out, lock down, manage version control. Reports are managed as a definition file that can be checked into source code control, and then developers can modify the report, deploy it to development, submit it for testing. After the report is tested and it passes our quality assurance standards, then it can be deployed to production. So version management is very important. Managing reports within a project as a group and perhaps deploying the entire project out to a folder or a server is also very important. Having a methodology and a product lifecycle cadence of development, testing, and deploying to production, also a critical part of managing reports in this way. So the theme here is not so much simplicity, but it's sophistication. Now let's get into the nuts and bolts of reporting services. I want to reinforce that reporting services is a server-based enterprise-scale reporting solution. And that means that it works with standard technologies such as Windows services, web services. Reporting services is exposed on a web server using http.sys. That's a service that manages web content without the overhead of actually installing a formal web server. It's actually part of Windows Server and has been for many years. So you can see here in the green area the subsystem of reporting services. On a report server, we have services and components that manage remote procedure calls, that listen for HTTP requests and then serve out responses to those requests. There's a security sublayer that makes sure that every request is properly credentialed, authenticated, and authorized to reach reports and the data that reports will present. Then we have the web portal application there in the dark blue. So the web portal is the menu or the front end of reporting services. Reporting services itself has a web endpoint, which we're calling the reporting services web service. And that is an ASP.NET web service that receives requests, passes them to the appropriate components to be processed, and then responds to those requests with content. The core processing engine is a collection of components that actually take care of managing security, data access, rendering, and the delivery of reports. And then at the bottom of the whole thing is what we call service management, which really is just a category of Windows services and components that make the whole thing work. Down in the lower right-hand corner, you can see that when a report server is set up, it has a set of configuration files. And there are default settings that are set up for you automatically on a server that's installed without any special configuration. But we can modify defaults and we can add components. We can provide extensions to reporting services and also change configuration settings when debugging and troubleshooting so that we can get more log information and auditing information so that an administrator or a solution architect can tune, troubleshoot, and improve the server. The report server, though it's installed with SQL Server, doesn't have to be on a SQL Server relational database server. In a scaled-out architecture, the database server itself could be on a separate machine altogether. In this case, the report server is seen as a separate server, and it maintains a connection to a SQL Server database server. The database server manages the report catalog database, which really consists of two different databases, the main report catalog database and the report catalog temp database. These are databases that actually manage report content and all of the objects, the scheduling objects, the security, everything that makes reporting services work is all managed in a SQL Server database within the report catalog database, typically called report server. The report catalog temp database holds temporary objects. So that's volatile information like instance caching information. So if the server needs to be restored, it's critical that the report catalog database is backed up and that that's restored. But the report catalog temp database is just used temporarily to manage those temporary objects. So at a high level, this is the architecture of reporting services. I think the takeaways are that it's a server-based architecture. It's not something that you just install on your desktop and use in a very small-scaled environment. Installing reporting services. Using SQL Server 2016 Installation Center, you run the Installation Center, or you simply run Setup, and that opens the Installation Center, which has a series of wizard pages. It's a very familiar installation paradigm. If you've installed earlier versions of any SQL Server components, then it'll be very much the same as what you're accustomed to. For our purposes, we will install reporting services into its default mode, which is what we call native mode. That means that it's not integrated into a SharePoint server, which is also an option. We will also install reporting services into a default instance, but reporting services can be installed into a named instance, which just simply means a non-default instance of SQL Server. In a scale-up scenario, reporting services doesn't have to be installed alongside the relational database engine. It can be installed into its own named instance, so we could have SQL Server in one instance, perhaps on one server, and then reporting services in another instance, which could optionally be installed on another server. And in reality, you could have multiple instances of either the relational engine and or reporting services installed into different instances. For our purposes, we're just going to install both of those services together. Then, after you have installed the SQL Server Relational Database Engine and SQL Server Reporting Services, you use the Reporting Services Configuration Manager to finish the server configuration. This is a necessary step to get your report server running, but it's fairly straightforward and easy to do. Once you have installed SQL Server Reporting Services, you navigate then to the Report Web Portal. This is the native and default user interface used both by administrators to set up, manage, and secure your report server and the report server content, as well as for users to be able to access reports and other content stored in folders within the report server. It's a very user-friendly and modern web portal environment. A new feature in reporting services is that the web portal supports the concept of favorites, so that rather than having to navigate through a lot of different folders and dismiss a lot of reports that may not be pertinent for a user, they can simply favorite the reports that they want. By default, that's what they see when they navigate to web portal. Reporting services now has a modern report view. It's a flat, very familiar and modern interface. Everything is rendered in HTML5. It supports modern web browsers and will work across a variety of devices and web browsers on different operating systems. All right, let's look at the sources of report data that are used within reporting services. By far the most common source of data typically are relational databases like SQL Server, Oracle, Teradata, and other systems that manage transactional data stores. Now, a relational database can be used in a few different ways. One for managing live transactional data like a point of sale system or a customer management system where the data is constantly being written to the database. And there are a lot of tables with referential keys and constraints that enforce the rules of integrity between the data in each of these tables. Those databases tend to be complex, and writing queries against them can be complex when you need to be able to extract and aggregate a lot of that data. Another role for a relational database is a dimensional schema that has been simplified for the purpose of reporting. Typically, a dimensional schema resides in a data warehouse or a data mart, where we have fact tables and dimension tables that keep the data as simple as possible, optimized for read-only reporting, and then that data is updated using an extract, transform, and load process, which may occur once a day, maybe at the end of the week, or perhaps every few hours throughout the day in a very high volume environment where the data is changing a lot, but it's not live data that's being changed all of the time. Another source of data may be a semantic model. Within the Microsoft data platform, we use SQL Server Analysis Services to manage a special set of data that is optimized for analytic purposes, for reporting and read-only analysis, where the data is stored in predefined hierarchies, in dimensions with attributes and hierarchy levels, in facts with measure groups, and then they have measures and calculations predefined within cubes and tabular models. These models tend to be much faster and easier to consume using tools like Excel and Power BI Desktop. Reporting services can also be used to build analytical and dashboard-style reports against these semantic models. There are a number of specialized data sources as well, like web services and data feeds, files, unstructured data sources like big data solutions, distributed and document-based data stores. Reporting Services has the capability of utilizing a variety of different data sources using standard data providers and connectors.
We'll take a look at the sample database that we will be using in this course. This is a new database from Microsoft, released with SQL Server 2016, called the Wide World Importers DW. Now, there are a couple of different versions of this database. There is an OLTP, or a kind of a transactional schema version of this database that has a little more detail. This is the data warehouse schema, as you can see from the name of the database here. And as such, it has fewer tables, but a larger volume of what we call fact data. So if you're familiar with a star schema or data mart or data warehouse, this is a fairly straightforward example. You can see that both the staging or integration tables as well as the data warehouse fact and dimension tables are all in this same database, just because it's a simplified example. Let's take a look at some of the dimension tables. So for example, this is the customer dimension. Now, in this scenario, Wide World Importers is an importer or supplier of toys and novelties. And so customers are the stores that buy those toys and novelties from us. So here in the customer dimension table, you can see the customer key, which is an integer, and then there are the customer names. The date dimension table is a fairly straightforward date dimension that's commonly used in just about every data warehouse I've worked with. In this case, the key column is a date type, which is a little different than the integer type or Kimball style date keys that were once very common. And then columns within this table represent different date parts. So one record in the date dimension table represents a day, and then different columns will tell us the year, the month, the quarter, etc., that day falls in. These dimension tables are related to fact tables. Now, in a data warehouse schema, whether or not there are actually relationships to enforce referential integrity between the dimension and fact tables is actually immaterial, because the purpose of this database is to be a read-only reference of data to run read-only queries against for reporting and analysis. And the integrity of the data, or what we call the conformity of the dimension tables, is actually enforced in the integration or the ETL process. And so each of these dimensions is related to a fact table through a primary key, foreign key logical relationship. So for example, if we look at the order table, you'll see that I have a customer key that relates to the customer dimension table. I have an order date key that relates to the date table. I also have a picked date key that also relates to that date table. And you see examples of other keys that are also related to different dimension tables. Now, because there's still a fair amount of complexity within this database, we will commonly create database objects like views, functions, and stored procedures to further simplify the ability to query this database. And that's what I've done here for this course. Earlier, you ran some script that created these 4 views. So here's an example of a view that we'll be using in one of the first reports that includes the year, month number, the month label, the order date key, state, customer, and then we have the quantity and the total from the order table. So rather than having to join all of those tables together in a complex query, we can just select from this view and we can still group, aggregate, and filter this data. Well, that's a quick tour of our sample database, and now we can start writing queries and running reports against this database.